Hello everyone, welcome to the ITLS Academy. Today we are going to discuss another topic that is your synthetic polymer. Okay, so before starting the lecture, we have to know that what is the synthetic polymer. Okay, so what is this polymer? First of all, we have to know that simply polymers are what they are large molecules made up of repeating unit called monomers. Repeating unit which is called monomers. Simply, okay. Simply it is what? It is a large molecules which is made up of a repeating unit. That unit is called a polymers. Or you can also say said that this polymers are what? They are a high molecular mass macromolecules which are made up of repeating unit which is derived from a monomers. Okay. Now, these polymers are what? Either they are natural or either they are synthetic. Natural polymers are those polymers which are present in nature. Okay. That is naturally present. But this synthetic polymers that we have to discuss, they are made up by a chemical reaction. Okay. They are man-made. The synthetic polymers are what? They are a man-made. Means that it is prepared by a human being, man-made, and the rest are same. They are man-made macromolecules which are created from a different chemical reaction. It is very important. Okay, so this is your synthetic polymers. Okay, now some example of this synthetic polymers like your nylon, polyester, and Teflon, PVC, etc. Teflon, PVC, etc. So today in our lecture, we have to discuss about the synthetic polymers. Now let's start today's lecture. First of all, we have to know that the basic concept of this polymers or the definition of this polymers. A polymers is a giant molecules which are made up of a large number of repeating units joined together by a covalent bond. Suppose that this is your repeating monomers. A. Now this A are joined together. Okay, and these bonds are called what? It is called a covalent bond. Okay, the simple compound from which polymers are made are called a monomers. Okay, so this is what? This is your repeating unit. Now this repeating unit is called what? It is called a monomers. Means that the monomers is the smallest unit of the polymers. Okay, so this is this repeating unit is called a monomers, that means that this monomers are joined as a covalent bond. Okay, The word polymers are derived from a Greek word that is called a poly. Poly means many and meros means part. Okay, means that this polymers have a many part. That means that it is derived from a Greek word. Polymer molecules have a molecular weight in the range of several thousands or more, and therefore are also referred to as a macromolecules. Okay, so we all know that these polymers are also referred as what? They are also referred as a macromolecules because their molecular weight are in the range of several thousands or more, means that the larger molecular weight. And therefore, this is illustrated by the following equation which shown the information of the polymer polystyrene. This reaction will be in the next slide. See, this is your reaction. Here it is a styrene. Styrene are what? It is a monomers. Here you say that this is your ring, okay, this. Okay. Now here carbon and hydrogen are present, and this carbon and hydrogen have a double bond with a CH2. Okay. Now when this styrene join together, then it form what? It form a polystyrene. This polystyrene is what? It is a polymer. Several styrene are combined together, and this combination are occur with a covalent bond. Here you said that you see that here the double bond are broken and it converted into a single bond, and here hydrogen are again form a bond with a another CH, okay, CH2, and here this, like this. Okay. Now again what you have to do, you have to form a this polymers when a n number of this styrene are combined together. So this is the explanation of this reaction. Now the next is the styrene molecule is the monomer, and the resulting structure enclosed in a square bracket is the polymer polystyrene. Okay, we all know that the starting molecule, that is your styrene, is what? It is a monomers which are made up of one unit. Now this monomers, this styrene join together, okay, like n time. Then the structure which are present in a square bracket are called a polymer polystyrene. The unit in a square bracket is called the repeating unit. Okay, so which are present in a square like this. Okay, this is what? This is your repeating unit. Some polymers are derived from a mutual reaction of two or more monomers. Okay, so there are also a concept of that polymers are also derived when there is a mutual reaction occur between a two or more type of monomers. Suppose that uh, I told you that like A form, then this is your same type of monomer. Now suppose that A form a bond B and B form a bond with C. Now this will come under the next category in which there is a mutual reaction between the monomers and then polymers are formed. For example, poly, that is your hexamethylene adimide, and next is your nylon 6,6, which are made from the reaction of hexamethylene diamine and adipic acid. Okay, here you see that when hexamethylene adamine and adipic acid, these are the what? These are the monomers. When they are react together, then they form a polymer, that is your polyhexamethylene adimide nylon 6,6. Here this which are under the bracket, just a minute, which are under the bracket are considered as a poly, polymers, this unit. Okay, so this is the explanation of this reaction. Now come to the next one. Now the next is, for molecules to be a monomers, for a molecules to be a monomers, it must be at least bifunctional. Okay, we consider a molecule as a monomers when it at least have a bifunctional. The functionality of a molecules referred to as a interlinking capacity or the number of site it has available for a bonding with other molecules. Okay, here the bifunctional means that bifunctional means that okay, interlinking capacity means that the number of sites which are available for the bonding with the other and molecules. Okay, suppose that this is your A. Now this A have a form with B and here this form bond with a C. Now this A has a two side, okay, two side for the bonding with the other molecules. Okay, same as it is. Now here it B have three side. Okay, so this will come under the category of bifunctional. Reaction between the monofunctional molecule use up the reactive group completely and render the product incapable of further reaction. Whereas the presence of two condensable group in both, that is your hexamethyl amine and adipic acid, make each of these monomers bifunctional with the ability to form a polymers. In this respect, styrene is also a bifunctional monomers because the extra pair of electron in the double bond can form two bonds with a vinyl group in other molecules. Now the next is the number of repeating unit in the polymer structure is indicated by the index n. Okay, in a first structure you see that the number which are present in a bracket like this. Okay, here this is a repeating unit. It is represented by a index n, and this index n is known as a polymerization, sorry, degree of polymerization or dp. This n is what? It is a dp, that is your degree of polymerization. It specifies the length of the polymer chain. Okay, this n will decide the whole length of the polymer chain. Oligomer is very low molecular weight polymer, usually with less than 10 repeating unit. Okay, if we talk about the oligomer, then they are what? They are a low molecular weight polymers and they have only, they have a repeating unit less than 10 unit. The word oligomer are derived from again a Greek word, that is your oligos, which meaning few. Okay, and mers mean the part, few part. Oligomers different thermal and mechanical property which is compared to the corresponding high molecular weight polymers. Okay, so this oligomer are what? They are a low molecular weight polymers. So their properties, their mechanical properties are totally different from the corresponding higher molecular weight polymer. Even the thermal properties and the mechanical properties are both. It is sometime useful to prepare a oligomers with a certain functional group at the end that can be used in further chemistry. The degree of polymerization represent one way of quantifying the polymer weight or size of the polymer. Now let's discuss one example, that is a linear polyethylene that consists 1000 ethylene unit. Okay, if we talk about a one linear polyethylene, they contain what? They contain a 1000 ethylene unit that have a molecular weight around 28,000, and it will extended the length 2520 angstrom. Here it is represented in a diagram. See this. However, because of the rotation, the carbon the carbon-carbon bond, the polymer chain are seldom extended to their full counter length, but are present in many different shape or non-conformatory. Here you see that. It is what? It is a schematic structure of fully stretched polyethylene. Okay. Now the next is your classification of the polymers. Okay, so these polymers are first classified on the basis of their origin. If we talk about on the basis of their origin, then either they are what? They are natural. Mm, mm. Either they are natural or they are synthetic. Okay, that I already told you. Natural are what? Natural are present in nature. These natural are what? They are present in a nature, and the synthetic are what? They are man-made. Okay. So it is based on a origin of the polymer. Now there are a certain polymers like your nucleic acid, proteins, cellulose, natural rubber, wool, silk are found in nature. Okay, so these are what? These are the example of the natural polymers like nucleic acid, protein, cellulose, natural rubber, wool, and silk. Now the next is your clay, sand, graphite, and diamond. They are also the example of the natural polymer. Okay. Now, if we talk about the other hand, there are 1000 polymers which are synthesized. There are thousands polymers, and more are likely to be produced in future. In some cases, natural occurring polymers can be produced by our synthetic routes. For example, polyisoprene is the synthetic version of natural rubber. Okay, so there are some synthetic polymers which are which are the origin of that which are the produce or you can say that this, they are the version of the synthetic polymers like your rubber is about rubber is a natural polymer, but they are what? There is also a synthetic version of that natural rubber, that is your polyisoprene. Okay, now the next is your on the basis of their functional present in a repeating unit. In this respect, polymers can be grouped in families like polyester, polyamides, polyamides, polycarbonates, polyurethanes, polyureas, polyethers, polysulfides. Okay. Now, on the basis of this polymer structure, polymers are either linear, either branch, cross-linked, ladder, star shape, comb shape, dendritic, and the like. Okay, see here. Here, this is your what? This is your linear, like this. Okay, this is your branch. See, the branch are present in that type of polymers. Cross-link. Here, the linkage are formed between the chains. This is your comb shape. See, this is your comb shape. This is your star shape. This is your ladder shape. This is your dendritic shape. So these are the systematic representation of the different polymers structures. Now the next is your amorphous or crystalline based on the absence or presence of long range order pattern among a polymer chain. Okay. Uh, Amorphous or crystalline, which is totally based on either there is a presence or absence of a long range order pattern among a polymer chain. Next is your homopolymer. Homopolymer or copolymer. They are what? They are a different type of the copolymers. Fibers, plastic, elastomers. polymers can be divided into various families like your fibers, elastomers, plastic, adhesive. Okay, polymerization mechanism. It is based on a polymer forming reaction, condensation versus addition or step growth versus chain growth polymerization reaction. Preparative technique like your bulk, solution, suspension, emulsion and precipitation. Thermal behavior, either they are thermoplastic or thermosets. And use, okay, like your dye-in polymers, they are what they are produced in a rubber industry. Olefin power polymers, they are produced in a sheet foam fiber industry. And acrylides, they are what they are a coating and decorative material, what they are acrylics. They are what they are a coating or decorative material. Now the next is your elastomers. Elastomers are a polymeric materials with irregular structure and weak intermolecular attractive force. Okay, these elastomers are what they are a polymeric material. Okay, and they are also a irregular structure, and there is a weak intermolecular attractive force present in this elastomer. Suppose that this is your elastomers. Now what happened? They join together. Okay, but the intermolecular attractive phase of forces are very weak. Elastomers are capable of high extension up to 1000 under a ambient condition. That is, they have a particular kind of elasticity characteristic of rubber. Okay, that's why they have what they have a elasticity characteristic of the rubber. The elasticity is attributed to the presence of chemical or physical cross-link in these materials. In their normal state, elastomers are amorphous, and as a material is stretched, the random chain are forced to occupy more order position. Releasing the applied force allow the elongated change which is returned to more random state. Thus, the restoring force are often elongation is largely because of this entropy present into it. So this is the basic of the elastomers. Now come to the next slide. See, here it is a random coil. Now here, if the tension create, then it will oriented like this. Now when the tension are released, then again it back to the normal one. Okay, here the diagram represented the illustration of rubbery elastomeric property. Here A is in the relaxed form. It is what it is in the relaxed form without any tension. Okay, or when there is no tension, when it is in like relaxed form, then the entropy is high. Okay, at that case entropy is high. Now the B is what they are stretch form. Okay, here the tension are applied. Now when tension is applied, then the relaxed form are converted into a stretched form. Okay, now when it is converted into a stretched form, then the entropy become low. Okay, now the next is your, in addition to natural rubber, there are synthetic elastomers like your dye elastomers. polybutadiene, polyisoprene, polychloroprene, and so on. Okay. First, these synthetic elastomers are what? Either they are diene elastomers or non-diene elastomers. Diene elastomer like your polybutadiene, polyisoprene, chloro, uh, chloroprene, and if it is considered as a non-diene elastomers, then they are what? They are either polyisobutylene, uh, polysiloxane, polyurethanes, and nitrile and butyl rubber. Elastomers can be made up from a block copolymers which contain a hard or rigid segment of polyurethane and soft or flexible segment which are derived from a polyester or a polyether diol with a degree of polymerization generally above 15. Okay, so here the degree of polymerization are what generally above the 15. Polyurethane elastomeric material exhibit good abrasion resistant, chemical resistant, and good tear strength with a wide variation of flexibility available. These polyurethane are also used in fabrics and sporting goods. Okay, see, this type of polyurethane are used in the fabrics and even the goods which are used in a sports. Okay, so the next, come to the next slide. See, this is your isopropene. Here cis 1,4 polyisoprene. This is your natural rubber. Here this is your polyether or polyester. Then it is combined with a aromatic diisocyanide in excess. Then it will convert it into ultimately hard segment, soft segment. Okay. This hard segment are what they are unreactive. These are the example of the synthetic elastomers, polyisopropene and polyurethane elastomers. Okay, this is your hard one. Water hard one is your like polyisoprene, and the soft one is your polyurethane elastomers. Okay, now the next is your fibers. Okay, so fibers are typically defined as the object with a length to a diameter whose ratio is at least 100. Fibers are either synthetic or natural. They are the polymers with higher molecular symmetry and strong cohesive energies between the chain that usually result from the presence of the polar group. Now, these fibers also have a high degree of crystallinity characterized by the presence of stiffing group in a polymer backbone and of intermolecular hydrogen bond. Also, they are characterized by the absence of branching or irregular spaced fibers are normally linear and they are drawn in one direction to make them long, thin, and thread-like. Okay, they are what they are like this. They are what they are long, thin, and thread-like with great strength along with the fiber. These characteristics permit formation of this type of polymers into a long fibers which are suitable for the textile applications. Now there are the example of the this fibers are polyesters, nylons, acrylic polymers like your polyacrylonitrile, and some natural occurring polymer like your cotton, wool, and silk. These are what? These are the example of this fibers. Here it is the diagram of synthetic fiber, polyester, nylon, and polyacrylonitrile. Here, this is your polyethylene tetraphthalate polyester. Here it is your hexamethylene diamine, suboxyl chloride. Okay, so these are the example of this. Now the next is your plastic. Plastic are the polymeric material with the property intermediate between the elastomers and fibers. Okay, if we see the properties which are in between the elastomers and the plastic, sorry, and the fibers. Then here the plastic are come. In spite of the possible differences in chemical structure, the demarcation between fibers and plastic may sometimes be blurred. Polymers such as polypropylene and polyamide can be used as a fiber and plastic by a proper choice of processing condition. Plastic can be extruded as a sheet or a pipe, painted on a surface, or molded to form a countless object. Okay, so these pipes are plastics are either used as a sheet, pipes, or painted on a surfaces, or even in a molded form to a countless object. A typical commercial plastic resin may contain two or more polymers in addition to various additives and fillers. Now, this additive and fillers are used so that they will improve the properties of this plastic, like the thermal processability, thermal or environmental stability, mechanical property of the final product. Okay. Now the next is your thermoplastic and thermosets. All polymers can be divided into two groups, that is your polyplastic and thermoset. It is based on a thermal processing behavior. Okay, so this classification are based on a thermal processing behavior. Totally. Now thermoplastic polymers soften and flow under the action of heat and pressure. Then, upon the cooling, the polymers hardness and assume the shape of the mold container. Thermoplastic, when compounded with an appropriate ingredient, then can usually withstand with a several heating and cooling cycle without suffering any breakdown. Now, the example of this thermoplastic are polystyrene, polyolefin, polyethylene, and polypropylene, nylon, polyvinyl chloride, and polyethylene tetraphthalate. Okay. Now the next is these are the example of the commercial thermoplastic. First one is your ethylene. Ethylene is converted into a polyethylene. Okay, see, ethylene is what? Ethylene are the monomers, and here it is converted into a polyethylene. It is what? It is a polymer. Then propylene, it is converted into a polypropylene. Again, vinyl chloride, it is converted into a polyvinyl chloride. They are what? Here it is the monomers, and then when these different monomers are combined together, then they form a polymers. Now the next is your thermosets. Now, thermosets are those polymers whose individual chain have been chemically linked by a covalent bond during a polymerization or by a subsequent chemical or thermal treatment during the fabrication. The thermosets are usually exist initially as a liquid, that is called a prepolymers. Now they can be shaped as we desire and formed by the application of either heat and pressure. Once formed, these cross-linked network resist a heat softening, creep, and solvent attack, and it cannot be thermally processed or recycled. Now, this type of properties of the thermosets are suitable for the composites, coating, adhesive application. Now, the example of this thermosets are epoxies, phenol, formaldehyde resins, unsaturated polyester, and vulcanized rubber, which are used in the tire industry, or also the example of thermosetting polymers. Now, thermosetting polymers are usually insoluble because they are cross-linked, cause a tremendous increase in molecular weight. At most, thermosetting polymers only swell in the presence of the solvent as a solvent molecule penetrate the network. For example, phenol formaldehyde to yield a phenol formaldehyde resins. Okay, here what happened? Here the molecule um, soak the solvent, or you can say the solvent in penetrate inside the molecule network and swell it. Okay, now the next is here it is the diagram of which represent the um, structure of phenol formaldehyde resins. Novolog form under a acidic condition and resolve form under the basic condition. So this is all about the like basic of this synthetic polymers. I hope you will understand, but if you have any query related to this topic, you can ask me in a comment box. Any information you want to know, you can ask it into a comment box, or for a further detail or anything else, you can follow the ITLS Academy on different platforms like Instagram, Facebook, Twitter, YouTube, WhatsApp, and LinkedIn, and get our app from a Google Play and subscribe our channel ITLS Academy on YouTube. Or you can also ask your query to the helpline number that are already mentioned in your slide, that is 7080833450, and visit our website www.itlsacademy.com. Thank you for watching. Please like, share and subscribe our channel.